Okay, in this video I'm going to find the stable matrix for this absorbing matrix A, and I'm going to do the calculations by hand. In this matrix A we see two absorbing states, and those are in the first two columns. That you have to be sure that those absorbing states are always up front. This allows me to partition the matrix. This identifies two matrices, S and R. Now the stable matrix is going to be a 4x4 matrix with the identity in the top left corner, zeros all the way across the bottom, and then in this top corner right here I have to make the calculation S times I minus R inverse. That's what's going up in the top corner. The calculation that we can do first of all is I minus R, which is 0.3, 0.1, 0.6, 0.2. Okay, and I end up with a matrix 1 minus 0.3, that's 0.7. 0 minus 0.6 gives me a negative 0.6 in that spot. 0 minus a 0.1, and 1 minus 0.2 gives me a 0.8 in that spot. So there's I minus R, step 1. The next step is to find the inverse of that matrix. So the 2x2 determinant method is going to be the quickest way to find the inverse. I'm going to calculate the determinant, and that is going to be product of the entries on the main diagonal, 0.7 times 0.8 minus negative 0.1 times negative 0.6, and that's 0.56 minus 0.06, 0.5. The inverse I'm going to get by taking 1 over 0.5, which happens to be 2. I'm going to take 2 and I'm going to multiply the matrix that I get when I interchange the two entries on the main diagonal. So put the 0.7 down at the bottom, 0.8 up at the top, and I multiply by negative 1 the elements on the other diagonal. Since they're already negative, what's going to happen there is it just turns them positive. And then I go ahead and multiply through here by 2, and I end up with 1.6, 1.2, 0.2, and 1.4. So there is the matrix I minus R inverse, and this is also known as the fundamental matrix. Now the last step is to multiply that by S. So one multiplication and I'm done. The matrix S that I identified back up here, let's take a look at it. 0.10, 0.5, 0.2. So it's 0.10, 0.5, 0.2. I multiply on the left by S, the fundamental matrix on the right. That's that matrix. And with one multiplication, I will then have the matrix that I'm going to put back in the top corner to find the stable matrix. So let's see, 0.1 times 1.6 is 0.16 plus 0. 0.1 times 1.2 plus 0, 0.12. 1.6 times 0.5, jot that down here, that's 0.8, plus 0.2 times 0.2 is 0.04, so 0.84 goes there. And then I multiply 0.5 times 1.2, that's 0.6, plus 0.2 times 1.4 is 0.28, and that'll be 0.88. So this matrix right here is the one that I'm going to put right back up in the top corner. Here's my stable matrix. It's going to be a 4 by 4 matrix. Zeros across the bottom two rows in the top position. I put this matrix, which is S times I minus R, inverse. And this gives me the long-term result. It says that 16% of the objects that started out in state 3 will be absorbed into state 1, and 84% of those objects from state 3 will be absorbed into state 2. For the objects in state 4, 12% of them get absorbed by state 1, and 88% of them get absorbed by state 2.